Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here is a problem for today for exam IFM. Let S of t denote the price at time t of a stock that pays dividends continuously at a rate proportional to its price. Consider a European GAAP option with exercise date t, where t is greater than 0. If the stock price at time t is greater than $100, the payoff is S of t minus 90. So you see that's the key meaning of what that GAAP option works like is the price that triggers the option is different than the price the payoff is based on. Otherwise, the payoff is 0. You are given that S of 0 is $80, the current price. The price of a European call option with expiration date T and strike price $100 is $4. The delta of the call option is named just above in part 2, so a regular European call option is 0.2. Calculate the price of the GAAP option. And here's the solution. So the strike price, K1, is 90, while the payment trigger is K2 equal to 100. The formula that gives the price of a GAAP call like that is very much like the Black-Scholes formula, but with some modification. It's S e to the minus delta t times n of d1 minus K1, the strike price, e to the minus rt n of d2, but d1 is based on K2, the payment trigger. d1 is, again, very much like the Black-Scholes formula, but with the payment trigger used is instead of the payment present value of exercise price. So this K2 e to the minus rt is put here, and this is that price, the payment trigger, while in present value of exercise price in the price of the option part, it's K1 that we see here. And D2, natural logarithm of S of e to the minus delta t over K2 e to the minus rt, the standard K2 e to the minus rt, the standard formula, plus 1/2 sigma squared t over sigma squared of t, and d2 is d1 minus sigma squared of t. So note that d1 and d2 are computed just like for a regular call option with strike price K2, the payment trigger again. The delta for regular European option is e to the minus delta t n of d1. So it's 0.2. The price of a regular European option is 4, equal to S e to the minus delta t times n of d1 minus K2 e to the minus rt n of d2, so that we end up with 4 equals 80 times 0.2 minus 100 times e to the minus rt n of d2, or e to the minus rt n of d2 equals 0.12. Well, we use that information, plug it into the formula for the GAAP call price, and end up with 80 times 0.2 being S e to the minus delta t times n of d1, minus 90, remember, K1 is 90, 90 times 0.12, which is the value of e to the minus rt n of d2. And now we just calculate that, and it's 5.20, and that's answer B. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. And good luck in your studies, and good luck on the test.